we are going to talk about an important element called carbon. Carbon is abundant in living organisms, and we actually use a lot of substances that actually contain carbon. Perhaps you already know from biology that the nutrients, the proteins, the carbohydrates, the lipids, and also vitamins have carbon in them. Okay, and carbon is occurring in these nutrients together with hydrogen and oxygen, and then other groups of other chemical groups also attached to the different nutrients that I've just said. Okay, so this is basically to illustrate to you how important carbon is. Perhaps you have also used charcoal at home. Okay, that charcoal that you use for cooking food. Are you aware that that is actually carbon? Yes. So that charcoal that you use is a form of carbon, and we are going to know what form of carbon is it. So therefore, in this presentation, we are going to be looking at, we are going to be understanding carbon, which group does it belong to, which period, what number of electrons does it have, and then we'll look at the properties of carbon, and then we'll look at the allotropes of carbon, where we shall look at graphite, diamond, and then amorphous carbon. Okay, and for each of these allotropes of carbon, we shall look at their uses. Okay, so that is going to be our presentation today on carbon. So carbon is represented by the symbol C. Carbon is represented by the symbol C, and that C is capital C. That is the symbol for carbon. Carbon belongs to group 4 and the period 2. Okay, group 4 meaning that it has 4 electrons in its outermost shell, and period 2 because it has 2 shells. So it has an inner shell, electron shell, and then the outer shell. Okay, so inside we have 2 electrons, and then outside we have 4 electrons. So therefore the electronic configuration is 2 to 4. Okay, that is the electronic configuration of carbon. Okay, carbon is a solid. That's something that we need to say from the start. It's a solid element. It occurs in different forms. It can occur independently or in free form, okay, without being attached to another element. Okay, so we say it is in free state. We can have carbon. Okay, so the free forms of carbon include diamond and graphite. Okay, and then it can occur when it is combined with the other compounds. Okay, we have coal, we have minerals, we have carbonates, where we have limestone, marble, seashells, and all living organisms. Just like what I said earlier on, that carbon is found in a number of the foods that we eat, whether it is the fish or that is vegetables. So even us, we have carbon. Our body is made up of carbon. We have carbon in our tissues. Okay, so plant and animal tissues contain carbon in combined states. Remember the hydrogen, the oxygen that I talked about earlier on. This is basically what we are referring to. And then it can be in synthetic form. This is where it is not naturally occurring carbon. It is carbon that is made from by man, okay, manufactured by man. So this is what we call synthetic forms: coke, charcoal, and carbon fibers. These are examples of synthetic forms of carbon. Okay, so carbon is very abundant and very important for life. Okay, and it forms 0.09% of the Earth's crust by mass. Okay, if you are to basically check the composition of the Earth's crust by mass, you find out that carbon forms 0.09%. Okay, we are saying that carbon exhibits what we call allotropy, which is a phenomenon where you have an element that is existing in more than one form, but without change of state. Okay, so you have carbon occurring in different forms, but does not change the state. Okay, so we have diamond, steel solid, graphite solid, and amorphous carbon. All these are the allotropes. If we ask you to name the allotropes of carbon, then you should be able to list that. Or if we ask you to basically name the allotrophic forms of carbon, you should be able to say diamond, graphite, and amorphous carbon. These are the three allotrophic forms of carbon. Okay, so this is basically to mean, I want to emphasize that carbon can exist in more than one form, but this does not change its state, and that phenomenon is what we call allotropy. Okay, so graphite, we are going to look at each of those allotrophic forms of carbon. So we are starting with graphite. Graphite is bonded covalently to 3 other carbon atoms to form hexagonal layers. Hexagonal layers, this is going to say that 6 sides. Okay, so we are saying that, for example, if this is our reference carbon, it is connected to one carbon, another carbon, and another third carbon, which we have not depicted in this picture. Perhaps we can use this one as our reference. So we have one carbon, one carbon, one carbon. So those are 3 bonds formed between carbon to carbon, or between 2 carbon atoms. So that therefore means that given that it is a covalent bond, basically the bonds are formed by sharing the electrons, right? If you remember that. So that means that one electron is not bonded. One electron is not bonded, and so it is freely moving within graphite. So we are saying that graphite, in graphite, the carbon atoms form covalent bonds with other carbon atoms, and therefore this leaves one electron that is freely moving. Okay, mobile electrons, and this is associated with the fact that graphite can actually conduct electricity because of that free moving electron that is not bonded. So the hexagonal layers are formed in they are existing in layers, one over the other. So in between the layers we have forces that we call the van der Waals forces of attraction between the layers, these dotted lines that you see here. Okay, and therefore these forces are not very strong, and therefore graphite is actually slippery. Okay, and you will see that that is actually very important in using graphite as a lubricant, as we shall see later on. So what you see here, this is graphite. Okay, so the properties include that it is having an open structure, so that it is not compact. Okay, that's what we are basically referring there. And because it is not compact, it has low density. Okay, we have said it is slippery because we have hexagonal layers that can slide over one another because of the weak van der Waals forces. We have an electron that is freely moving, therefore it is a good conductor of heat. It has high melting point, and it is opaque and dark, just like what you saw here. Opaque, that means you can't look through. Okay, light can't pass through. Okay, and then it's also dark. So we use graphite for a number of purposes. The pencils that you use, they are the points for writing are made of graphite. We can also use graphite as electrodes in electrolysis. You basically have looked at what electrolysis is, and you know some electrolysis procedures that require you to use graphite electrodes. Using them as lubricants because they are slippery to reduce friction. And then here we have a picture of what we call car brushes, for especially electric cars. Electric cars have brushes for electric motors. Basically, they move electricity from stationary parts, and also linking them to the rotating parts. Okay, such that the car can move in a smooth manner. Okay, so they are used in cars, especially in electric motors. Okay, and then we have graphite can be used for preventing rusting. So iron can be coated with graphite to prevent rusting. So we move to the next form, which is basically diamond. Here, unlike graphite, diamond is the carbon atoms in diamond are convariantly bonded to 4 carbon atoms. Okay, 4 carbon atoms. So if we are to use this as our reference point, so this is 1 carbon atom, this is another carbon atom, this is another carbon atom, this is another carbon atom. So that basically means that it is packed, it is compact, and that actually contributes to it being very hard, and also contributes to it being of high density. Okay, so it is the hardest substance known. It is of high density, high melting and boiling point. Okay, so we are saying that you have each carbon atom bonded through covalent bonds. Tetra, this here means 4. Okay, tetra means the prefix tetra means 4. Tetrahedral to 4 carbon atoms to form a very compact structure. Okay, a very compact 3D structure. Okay, so that is what diamond is. Okay, so if you were to draw diamond, the structure of diamond in your exams, we are expecting you to draw this image. Okay, illustrating that we have each carbon being covalently bonded to at least 4 carbon atoms in a tetrahedral manner. Okay, in a tetrahedral manner. Okay, so we have seen this. It's a non-conductor of heat. Why? Because there is no free electron. All the electrons are bonded. So movement of current or electricity is because of movement of electrons. So if an element does not have free electrons, then it will not conduct electricity. So it is not a conductor of what? Electricity. It is transparent, sparkling, and glittering, just like what you see here. So what do we use diamond for? Because diamond is the hardest material known, or the hardest substance known, it is used for a number of it has a number of uses utilizing that property. Okay, there is always a saying that iron sharpens iron. If diamond is not the strongest substance known, then it will not be used for some of these roles. These 3 roles are attributed to the hardness of being the hardest substance known. Okay, so we can use it for drilling. If you want to drill a hole, whether it is in a metal, whether it is in a rock, you use you can use a driller or another machine that is made up of diamond. That is very important to note there. So rock borers, glass cutters, these are all related to the hardness of diamond. And then it is shiny and transparent. It is good for beauty. So we use diamond for necklaces, rings, and other things that we can use for decoration. Okay, it can be a belt, it can be anything. And then you can use diamond for making what you call laser beams. So we look at the last allotropic form of carbon, and that is amorphous carbon. This is black and non-crystalline, low density, that means it is not compact, and it is fairly conductive, that means it can conduct some electricity to some extent. So the charcoal that we use at home is actually amorphous carbon, and it is what we call wood charcoal. Okay, wood charcoal. It is absorbent, that is to say it can absorb moisture, and it is made by burning wood in limited supply of oxygen or air. Okay, so that is wood charcoal. And then animal charcoal, still made in the same way, burning animal bones with limited supply of oxygen. It is used in removing color from sugar. And then we have sugar charcoal. This is the pure form of dehydrated sugar. That's where it is made from dehydrated sugar. And then black burning oils used in ink and shoe polish. And then coke, which is it is impure. It's used as a reducing agent in metal extraction and also fuel. So this is basically a table to basically break down the various forms of amorphous carbon. what they are, how they are actually made, and then what they are used for. So for wood charcoal, we have explained that the charcoal that you use at home is what we call wood charcoal. It's made by burning wood in limited supply of oxygen or air, and we use it for cooking in most cases. But we can use it as a good absorbent for gases, okay, especially ammonia, chlorine, and bromine. And then animal charcoal, you already know, it's made by heating animal bones in limited supply of oxygen. Okay, it also contains calcium phosphate, so it is not very pure. What do we use it for? If you get a snake bite, you can be given animal charcoal such that it can absorb the venom, which is the poison that the snake has injected into your body. Okay, so it is also used for purification of sugar. Okay, it removes the brown color from sugar, making it white. And then we move to sugar charcoal. It is pure carbon that dehydrates cane sugar and glucose, or glucose with concentrated sulfuric acid. So it is used in various scientific experiments as a reference point for pure carbon. So that if you want pure carbon, this is basically what is used as a reference point in different chemical experiments. And then lamp black, which is produced from burning petroleum, kerosene, turpentine, and candles in limited supply of air. So the tires that you have on cars, those tires are made from black carbon. Okay, and even the ink that we have in our printers, even the shoe polish and carbon papers, this is where it is made. Okay, so these are basically what you can call byproducts of oil refinery. Okay, purification of oil, you get this lamp black carbon that can be used for different uses. And then the solid left after burning, after heating coal in limited air, is what we call coke. Okay, and we use coke in furnaces and boilers and ovens. Okay, so carbon is a unique compound. It has the ability to be bonded to 4 other carbon atoms. That's one unique property. And then it can also form what we call long carbon chains. Okay, and this property is what we call catenation. So therefore, we have a lot of organic compounds that are formed because of that property of being able to make long chains. And the chemistry of carbon containing compound is what we call organic chemistry. Organic chemistry, the study of carbon containing compounds, is what you call organic chemistry. So some of the long chain hydrocarbons, the ethanes, alkanes, ethene and others, and other organic acids, you look at them under this topic called the organic chemistry. So that basically marks the end of this presentation, where we have looked at carbon, and we have said carbon is very abundant in living organisms and even in a number of the nutrients that we consume. So it exhibits very unique characteristics. For example, it exhibits allotropy, where it exists in more than one form but without changing its form. We looked at graphite, diamond, and amorphous carbon, and for each we have looked at their